Hi guys, we're moving on to look at Pythagoras theorem now, something we've seen before in Nat 5 and kind of second year, third year maths we touch on Pythagoras, so we just push it on a bit further at Nat 5 level, but we're going to start just with a kind of introduction and a wee reminder on kind of basic using Pythagoras theorem. So I'll run through this sort of introduction into how the theorem kind of works. If you have a right angle triangle like we have here with sides 3, 4 and 5, the biggest side obviously being the one that is 5 centimeters, if we were to square each side, literally draw a square on each side, so the side we've called A, the smallest side would be 3 by 3, which is of course 9, 3 times 3, 9. The other smaller side would be a square with 4 by 4, which would be 16 centimeters squared, and the biggest side would be a square of 5 boxes by 5 boxes, which is of course 5 times 5, 25 centimeters squared. So we get this rule where the 25 centimeters squared is actually equal to the two other squares added together. So 25 is equal to 9 plus 16, which we can summarise in this formula: c squared equals a squared plus b squared. So that's kind of fundamental Pythagoras theorem formula that you will hopefully remember a wee bit from before. So this is a kind of wee note that I think it's probably worth pausing the video just now and noting down. If you have a right angle triangle like this, we've got side A and side B. They're always the smallest sides. The longest side is always C. Now to spot the longest side, you just go to the right angle and you go to the side that's directly opposite it. That is always the side that we need to call C, and we get the formula c squared equals a squared plus b squared. So it might be worth pausing the video just now and just taking a wee note of that in your jotter. Right, so that is the formula we use if we are looking to find the biggest side, C, in a right angle triangle, and that's what we've got the top here to find C squared equals a plus b squared. But of course we might sometimes be looking for one of the smaller sides, so say that we knew what C was and we knew what B was, you basically just need to rearrange this formula a wee bit and we get a squared, which is this one of the smaller sides, is equal to c squared subtract b squared, right? And these two formulas are extremely important, and you do not get given them in the National 5 paper or anything like that. So again, these are two formulas that we must remember. Okay, so let's we're going to just start by doing an example, just one of each, basically one where we're finding the longest side, one where we're finding the smaller side. So that's the first two examples in our notes. So if you can get your notes now, the first two examples you'll see up here. So yeah, we've got this first triangle on the left hand side, which has two smaller sides, 6 centimeters and 4.5 centimeters. So we're given the smaller side. Again, the longest side is the one that is opposite the right angle, so it's the longest side we're looking for, which we're always going to call C. So it doesn't kind of matter what letters written there, we're always going to call that C. And the two smaller sides, it doesn't matter which you label A and which you label B, but you just need to know that those are the two smaller sides. So we get a calculator for these Pythagoras questions at all times, always. So we are going to basically just work out this longest side C. So we've got the formula, which is c squared equals a squared plus b squared, and then you're just going to put in the values of a and b, and we're going to work this out. So c squared is equal to 6 squared plus 4.5 squared. And what you've kind of got two options here. Either you could work out 6 squared plus 4.5 squared and write that down on the right hand side here, but what we have here is a c squared, which we're going to have to undo by doing the square root of both sides. Now if you work out the right hand side first, then take the square root, you can end up putting two different things in your calculator, and you can sometimes make a mess and get numbers wrong or not round it correctly. So it's much easier just to put it all in one go by doing the square root of this whole thing on the right hand side. So here's what I want you to have written down is the square root of 6 squared plus 4.5 squared. Now what you're going to do is you're going to go to your calculator, and if you have a Casio calculator, you don't have to worry about putting a bracket in or anything, but if you're using one of the black and white calculators, you are going to need to put this, what's underneath the square root, you're going to need to put that whole thing in a bracket. If you've got a Casio calculator, you don't need to worry about that, it does it automatically. So you're hitting the square root button, which you can hopefully all locate in your calculator, and if you need to open a bracket, type in 6 squared plus 4.5 squared and close your bracket, and you should hopefully get an answer of 7.5 centimeters, and that is us done. That's the length of the longest side. Okay, so moving on to the next example where we have another right angle triangle. This time the longest side is this one here. It's already given to us, that's C. So we're not looking for the longest side, we're looking for one of the smaller sides. The missing smaller side I always change to A, and the other one can be B. Okay, so this is where we're using the other form of Pythagoras theorem, which is starting with A squared is equal to C squared minus B squared. And pretty much from here on in, it's just the exact same. You just need to substitute the numbers in, remember that you're subtracting, and put it all in your calculator. So A squared is equal to 25 squared minus 7 squared, and A is equal to the square root of 25 squared minus 7 squared. Now, one thing to watch out for here, if you get these the wrong way around and put the 7 squared minus 25, your calculator will come up with an error. So if you're getting an error, just check that you've got them right. You can't take the square root of a negative number, which you would get if you did 7 squared take away 25 squared. So just check that you've got them the right way around, and then just put it in your calculator and you should be able to get the answer okay. So square root of 25 squared minus 7 squared, and you should hopefully get an answer of 24 centimeters. Okay, so all I want us to do now is to do a little bit of practice initially of these kind of basic Pythagoras kind of recap types before we move on to the more complex National 5 level ones. So if you can go to your Unit 3 books and turn to, I believe it's on page number 16. It's the very first exercise in the Pythagoras theorem topic in Unit 3, so page 16, and I just want us to work through question number 1.